Well, the big disagreement I had with Ray is I think after you get human level AGI, I think you're only a few years from superintelligence. And he said human level AGI 2029, singularity 2045. But I think his curve fitting is overfit to having humans do the invention. Like, I think once the AGI is doing the invention, the exponential growth curve becomes bigger, and I think it only will be a few years from a human level AGI to a super AGI, because that human level AGI will be able to program and invent new chips and invent new forms of networking and so forth. It seems like it should be able to upgrade itself pretty rapidly. If you train an LLM on music up to the year 1900 only, it's not going to invent grindcore, neoclassical metal, or progressive jazz. I mean, it may do cool creative things. It'll make up new songs that you never heard before. If you ask it to put West African drumming together with Western classical music, it may even manage to set Mozart to a polyrhythm or something, right? But to get to jazz and metal and world music and all this is just a number of creative leaps that I really don't think anything like a current LLM is gonna be able to take. LLMs will not be the central component in an AGI system. So if you're spending a lot of time trying to make an AGI system of which LLMs are the main piece, I think you'll mostly be wasting your time.
Dr. Ben Goertzel is a renowned artificial intelligence researcher, cognitive scientist, and entrepreneur, known for his pioneering work in artificial general intelligence. He's the founder and CEO of SingularityNet, which is a decentralized AI platform, and he's authored numerous books and papers on AI and complex systems and the future of technology, including his new book out on consciousness.
Okay, Ben. It's an honor to have you on MLST again.
Yeah. It's good to be back.
Yeah. So, do you feel the AGI?
Well, you can feel progress accelerating, right? And which is exciting. I mean, it's a different feeling with these AGI conferences the last few years than it was, say, 2006, 7, 8, 9 when we started. Because now, each year, there's really a lot of new stuff, just new ideas and new things working. So, I mean, it's not yet as fast a pace as you see with machine vision or NLP, but it's still palpable. Like there's quite different stuff happening each year than the previous one, and that's pretty exciting. I don't think we yet have the feeling at this event like the AGI is here, the human level AGI has been launched. Probably the folks in this community felt less that way about LLMs than the average person, because we're overly aware of what's under the hood.
Yeah, I mean, talking of LLMs, I mean, what are your reflections on the state of AI at the moment?
So the state of AI R&D is one thing. The state of AI in the commercial world is another thing. And of course, the state of AI as perceived by the general public is yet a third thing, right? And so I think in the R&D world, there's a great variety of threads of research going on. I mean, there are LLMs and deep neural networks, there's logic-based systems, there's evolutionary learning, there's attempts to formalize what is a general intelligence. There's great variety of different neural architectures behind backpropagation or transformer neural nets. So there's a lot in the R&D world, as there has been for many decades, and there's rapid progress in a whole variety of directions that even defies concise summary. I'd say the business world tends to be a little more herd animal-like than the research world. I mean, the research world can be like that too, especially funding sources. But the VC world is famously like that, right? Like something has one shiny success and suddenly everyone jumps on that exact thing. And one company does well with something, every company can't be left behind on that exact thing. So I think in the business world, obviously we've seen a huge enthusiasm for large language models and trying to see what they can do in different vertical areas. And that in a way seems to be reaching a peak now when people are sort of getting burned out, realizing they don't solve all problems immediately with no work. But I mean, I think they're still going to be a big success. People will just have to do a little work to fine-tune them and integrate them with other applications. But that's all about business and industry and hype cycles, which is a little bit off to the side of the R&D work, which is just more heterogeneous. And public perception, on the other hand, has evolved in a quite interesting way because, I mean, 5 or 10 years ago, most people outside of the technical AI field who I talked to thought AGI was indefinitely far in the future and didn't really want to think about it. And, you know, that was more true 30 years ago than 10 years ago, more true 10 years ago than 5 years ago. But I mean, the launch of ChatGPT really altered public impressions in a huge discontinuous jump, right? So a lot of people are like, well, AGI is here already. Okay, it's not exactly like humans, but close enough. And those who don't think that, they're willing to believe it when Elon Musk or someone says we're having human-level AGI next year, right? So the public perception has shifted to a remarkable degree, which is both good and bad, right? I mean, it's cool. It's cool that the goals that many of us have been working toward for a long time are now taken seriously. On the other hand, it's a bit scary that people are so naive about something so important. And I mean, this could lead to adverse regulations being put into place because people just don't understand what's going on and are thinking about it in very simplistic ways.
Yeah, I'd love to get back to the regulations actually, but just before we go there, do you think that LLMs are an off-ramp?
I think LLMs will not be the central component in an AGI system. So if you're spending a lot of time trying to make an AGI system of which LLMs are the main piece, I think you'll mostly be wasting your time. So in that sense, yeah, I mean, it's a pithy aphorism. LLMs are an off-ramp on the path to AGI. On the other hand, I think an LLM could be a non-trivial component of a multi-component AGI system. Now, whether that component would add 30% or 10% to the intelligence of the overall system, I don't know. I doubt it's 90%, but I also think it's more than like 1 or 2%. So I think they do contribute something significant, but I don't think they're the whole thing, right? And of course, I think in a broader sense, working on useful AI applications is for many people an off-ramp on the path to AGI, but still something that does good for the world, right? Because many AI researchers have started out trying to build AGI, then they realize it's long and hard, and you don't know how much progress you're making, and it's hard to get paid for it. But you realize you can make practical AI applications that make you money and do good for the world, and you just start doing that, right? And in that sense, LLMs are definitely an off-ramp because, I mean, people are doing a lot of cool stuff with LLMs, and then they're not working on the fundamental AGI problem. But on the other hand, they may be building amazing applications that enhance humanity, right?
Yeah, I mean, there's two schools of thought, right? So one is...
There's a lot more than that. There's a lot of schools of thought.
Yeah. I'll sketch out my perspective on...
Yeah,
I appreciate there's a lot more, but some people say that they are kind of N-gram models on steroids, and some people say that they have this emergent reasoning. I'll give you an example. I was reading...
They do have emergent reasoning. They just don't have enough or the right kind of emergent reasoning to be a human-level AGI, right? So, I mean, in context, few-shot learning is quite amazing. It's very cool, and the LLMs do improvise weird stuff that wasn't in the training data, right? Like you could craft prompts describing an alien civilization with 5 sexes and the love affairs among these different combinations of alien sexes, what's considered cheating or not among different permutations of alien polycules, right? Then you can ask the LLM, like, what will be considered unethical to what degree by which of these alien sexes, right? And there's nothing like that in the training data. You just made it up. And it can reason through that with great facility, right? So this is not exactly an engram model. On the other hand, it still isn't the flexibility and fluidity of generalization that humans can do, right? So you're not really accurate on either side. I mean, they're not just doing like Markov models and straightforwardly extrapolating data. There's weird self-organization happening in the activation space of a large model. On the other hand, they're still not able to leap beyond their training data with vaguely the level of oomph that the human mind can, right? And so they are sort of a new category of thing that we didn't anticipate before, which is interesting.
Yeah, it's so fascinating to hear you argue that they reason. I mean, I interviewed Sabaro Kambahati the other day. He had a paper called Chain of Thoughtlessness, and he said rather than teaching them how to fish with this kind of prompting, you actually teach them how to catch 2 fish or 3 fish or 4 fish, and at some point it's just limited by the prompt or what it can retrieve from its internal storage.
That's true. It is limited, and I mean at some point humans are limited also. Right? I mean, none of us can deal with math problems beyond the algorithmic information content of our brain, right? So we're not unlimited except in the theoretical case where you give us an infinitely long Turing machine tape to type on or something, right? But I think, there are still fundamental differences between the way that LLMs generalize and create and the way that people do, but it's an interesting theoretical challenge to pin that down in a rigorous way. I mean, you can say that a transformer neural net is not a Turing-complete model in itself, but if you give it a sketchpad to write on, then it is, right? So say, okay, well then take a transformer, give it a working memory as a different neural network, then it becomes a Turing-complete model, but it's still not doing what a human brain does and what an AGI system needs to do. So an example I've often given in the domain of music modeling is if you train an LLM on music up to the year 1900 only, it's not going to invent grindcore, neoclassical metal, or progressive jazz. I mean, it may do cool creative things. It'll make up new songs that you never heard before. If you ask it to put West African drumming together with Western classical music, it may even manage to set Mozart to a polyrhythm or something, right? But to get to jazz and metal and world music and all this is just a number of creative leaps that I really don't think anything like a current LLM is gonna be able to take. And certainly experimentation with UDO or any music gen, any existing music model, you can see the practical limitations here, right? It's pretty initially it's really cool. Like you can pick an artist to make an arbitrary number of songs in the style of that artist. It gets their voice right. You can make a competent metal guitar solo. On the other hand, it's all banal music in the end. Like you're not getting anything really awesome out of it, even within the defined genres that it knows, let alone inventing some new genre of music or some profoundly new style, right? So there clearly are limitations, which are more severe than the limitations we have, but it's not quite clear how to formalize or quantify those limitations right now.
Yeah, that's a great example. I saw a vision generator model. Oh, that's okay. I saw a vision generator model and they prompted it to generate for 1956, 1957, 1958, and you could just see the morph of the styles for all of the different years. And of course, when it went past 2024, it just ran out of distribution because there was no training data, so it kind of mode collapsed. But interestingly, if you went forward enough to about 2070, you started seeing Star Trek uniforms and so on. But my intuition though is, if these models are learning very abstract representations of the world, then why wouldn't they?
I don't think they are.
Oh, that's interesting. Why not?
I don't think they're learning very abstract representations of the world. Just from looking looking inside at what they're doing. I don't see how they could be. And when you try to use them to drive mathematical proof, which I've played with quite a lot because that's my original background, a PhD in math. When you try to use them to drive mathematical proof, they mix things up in very silly, basic ways that lead you to think if they're building an abstract representation, it's not the right one, right? Like it doesn't represent the actual mathematical structures. And in the case of math, there sort of is a correct abstract representation, and they're not getting it, right? Like you can, in many cases, give a proof sketch, and it will fill in the details of your sketch, which is interesting. You can even give a verbal outline of a theorem, and it will turn that into like a formal logic theorem statement. So it can do quite a lot of things, but then it will mix things up in very, very silly ways, which like no graduate student would ever do, right? And so it seems from that example, the abstractions it's learning are really not the ones that a human mathematician would use. And that's probably connected with the fact that, I mean, in the automated theorem proving world, which we had represented here by Joseph Urban from Czech Technical Institute, I mean, using LLMs to do theorem proving, I mean, that's not what they're doing, right? I mean, that's not what Google did with alpha geometry either, right? I mean, they use the LLM to translate Math Olympiad problems and such into formal logic, and then use different sort of AI system to do the actual math, right? So I think music is a domain where it's clear the creativity is limited, and it feels like the internal representation is not quite the right one to be profoundly creative. But math is a bit more rigorous, so when you see the sorts of errors it makes, it's really quite clear that it's not getting the abstraction right, even when it can spit out what the definition is. And this is the frustrating thing we've all seen. Like it will spit out the precise definition of, say, a non-well-founded set based on Axel's anti-foundation axiom. But then when you ask it to derive a consequence of that, it'll 70% of the time be good, 30% of the time come up with other gibberish, where like if you understood that definition that you just cited, you could never come up with that gibberish, right? So this suggests the representations are not really the right ones. I mean, theoretically, there's the other possibility. It has the right representations and is bad at selecting them and sometimes select the wrong ones. But if you dig in, it really seems not to be the case. And I think transformers are modeling things on the whole too close to the surface level, right? And they have so much data that modeling close to the surface level can let them go a long way. Now, it's not as surface level as a Markov model, but it's still too surface level to be a human level intelligence, right?
So we've been advocating for neurosymbolic models on the show for many years, and DeepMind now are doing neurosymbolic models. Yeah. So there's alpha geometry, fuzz
It's not
search,
surprising.
alpha proof.
I mean, as you know, or may know, I mean, Shane Legg, who co-founded DeepMind, worked for me in the late 90s, and we were doing Neuro-Symbolic stuff then, right? So I mean, they knew that was a thing, but Shane and Demis really wanted to be more biological, and so they had to bang on the biological fidelity thing for a while until it just wasn't doing everything they wanted. And then they're like, well, okay, we will substitute for this brain module a totally non-biological algorithm that does sort of the same thing that brain module is supposed to, right? So which is fine. I mean it's not at all surprising. Huh?
Yeah, I mean, could you explain why it's good? My kind of intuition is we need to have some kind of source of creativity. So we use a language model to generate lots of ideas, and then we have some kind of post hoc validation system, and there's a virtuous cycle between the two things.
Oh, I think the cycle you describe needs to be there to have a human level general intelligence, but I think LLMs are not really good at either the creativity or the validation part, actually. they're more like a knowledge resource that could be consulted by either of these parts.
I agree.
I mean, I would say evolutionary algorithms historically, in a way, are better at creativity than LLMs. And if you look in music generation, I would say work that I did in the 90s on algorithmic music generation with genetic algorithms came out with more creative melodies than you get out of video. I mean, it also came out with some noise. I mean, I was doing like series of MIDI notes. It didn't sound like a whole band right out of the box. But GAs are, in a way, better at creativity, which is not surprising. They're emulating evolutionary process. So one interesting direction of work will be to use LLMs to sort of guide and bias what evolutionary algorithms do, because the LLMs do have tremendous knowledge of what's been created by humans so far, which maybe could cut down the amount of time and memory it takes to use an evolutionary algorithm to generate new things. Now, I mean, I do think logical reasoning is one way to evaluate creative products to see how good they are, right? I mean, of course, not the only way. I mean, the basic idea of a GAN is you have an evaluator and a creator, right? So, I mean, you can have neural nets do evaluation also. I think symbolic reasoning is certainly, it's a key part of what makes human intelligence different than the intelligence of, say, dogs or worms or bunnies or something. And it's sort of an open question how valuable symbolic reasoning is if your goal was to make an artificial worm or even a mouse, right? So, I mean, if you go back to basic theory, in the theory of semiotics, a symbol is one of multiple kinds of signs, right? You can have an icon, which like resembles the thing that like an emoticon or something, right? This smiley face icon sort of resembles a smiley face. So you can have
indexical.
Yeah, you can have an index, like when the mercury in the thermometer goes up, when the temperature goes up. A symbol is a representation of something that doesn't have any surface level resemblance to that thing, but it enters into similar relationships with other symbols, paralleling the relationship that the represented thing enters into with other represented things. And, humans built these symbol systems, and mathematics and language are among these. The parts of a machine are among these, right? And obviously these are super valuable to us. And of course, programming languages and even like the registers inside a chip are also part of a symbol system. So in a way, AI programs exist in the world of symbol systems. Now you could argue that in evolution, the ability to manipulate and form symbols emerged from much more primitive faculties, right? So then what you should be doing is creating virtual animals using sub-symbolic methods, which could be neural nets or something totally different, and then get the facility for symbolism to pop out from that sub-symbolic level. And I think that's very interesting. It's a great research direction. I would love to see it happen. I've tried experiments like that myself with the same limited success that anyone else got. But then, if you're looking at how can we in practice make AI systems smart right now, even if not having full fidelity to biological evolution, I mean, computers are very good at symbol manipulation, right? So it's very, very tempting to take explicit symbolic manipulation and database engines, theorem provers, and probabilistic reasoning systems, take systems for explicit symbolic manipulation, which works so well on the symbol systems of our chips and programming languages, use these to do the things that they're good at, and then connect this together with sub-symbolic systems like transformers and CNNs and other neural nets to do the things that they are good at, right? And that certainly from a practical standpoint, it's very tempting. From a conceptual standpoint, you could view that as trying to architect a kind of mind that in some ways is better than the human mind. I mean, we're quite bad at mathematics, right? I mean, I was a math professor for a number of years. It's quite painful to get the average university student to understand even what feels to me like basic stuff. On the other hand, then eventually I hit a level when it's hard for me, and I have to struggle to figure it out, right? So we're not good. We're not good at math. We're not good at science. We put a lot of bugs in our software programs, right? So, I mean, by putting explicit symbol manipulation at the foundational level in a cognitive system, perhaps you can make a system that's better at advanced math, science, and engineering than people are, which could be quite beneficial. And you could even look at this from a machine ethics standpoint. Like our ethical frameworks are wildly inconsistent, and I mean I'm the same way. All humans basically are that way. Like when I visit Ethiopia, where we have a software development office, I see, starving people and kids out in the street, people dying of curable diseases lying by the side of the road, just walking from the hotel to our software development office, right? And then I give these people money.
Bad enough in Seattle.
It's not the same level, though. Yeah.
Okay.
Yeah. But yeah. But anyway, I give these people money, and then when I come home, I forget about it after a couple of weeks. Not really forget about it, but I'm not sending these people money. I'm trying to do good for them in various ways. We're injecting money into the Ethiopian economy by having a software shop there. But I mean, in the end, I feel much more for suffering I see in front of my eyes than for suffering which is thousands of miles away, right? And this is incoherent. I know it's incoherent. It's just how I am as a human being, right? It's quite possible an AGI system which has probabilistic logical reasoning as more of a core part of its wiring is more coherent in its ethical approach to the world, right? So I think there's pragmatic reasons to look at neuro-symbolic systems, because symbolic just suits the compute infrastructure that we have. And then there are more theoretical reasons in that, according to various criteria, a mind with a substantial symbolic component may just be better at doing some important things. The challenge then is, how do we make symbolic and sub-symbolic components work nicely together, right? Which is one among the research topics being discussed at the AGI 24 conference where we're now sitting.
Could you briefly discuss, in natural human intelligence, I mean, for example, Chomsky says that language is a system of thought. Other people think that it's a system of communication. And I guess one school of thought is that just like language is a kind of meta-emergentist organism, you could argue that symbol processing in of itself is actually an emergent thing. It doesn't necessarily happen all inside the brain. I mean, what do you think about that?
I mean, it happens both ways, right? I mean, of course, symbol system seems to have emerged culturally, right? I mean, language emerged for communicating between people about objects in their shared environment, and the same is largely true of languages of other animals like birds or other mammals, in as much as we understand them. And then, of course, we're making sounds. We're writing things down, right? So certainly, language emerged as part of the group mind of collections of people. And if you take a wild child who grew up with no human interaction during the first few years, like the developmental processes in their brain that lead to advanced linguistic functionality never get triggered, right? So, I mean, there there is that argument. On the other hand, I can lie in bed at night, close my eyes, and prove math theorems in my head, right? And I mean, then it's all internalized, right? I mean, I'm manipulating symbols in the theater of my consciousness. I don't need to write things down. I don't need to talk to anyone else, right? So we come by it culturally, but then, I mean, hypothetically, I can come up with new math concepts in my own mind and create theorems that deploy them, and there's no external interactions involved, right? So I mean, it's a bit of both. Then it's internal and external.
It's come up a few times on the show because there's a thought experiment that you're in a hermetically sealed chamber, and would you still be able to kind of think rationally and do all of this kind of stuff? And of course, if you know,
I mean, I've been in a sensory deprivation tank. And you people will tend to drift into wild hallucinations. On the other hand, if for some reason you tried not to, I didn't have a problem summoning a coherent, reasonable train of thought. It's kind of a waste of your time in the deprivation tank. Huh?
I mean, Stephen Hawking's given as an example, but if he grew up physically embodied and you know, exposed to all these external processes, then of course the brain can simulate them again afterwards.
Oh, you mean a human brain in its actual form has certain triggers for development, so that if these external environment triggers don't pop up, the next stage of development just won't be released, right? But that doesn't mean that's an intrinsic aspect of any human level intelligence, right? That's just how developmental neurology evolved, because we didn't evolve to be robust with respect to spending our childhood in a deprivation tank, right? I mean, evolution had no reason to optimize us for that. So I mean, but I would say this relates somewhat to an issue we've hit in creating OpenCog Hyperon, which is my own team's attempt to build an AGI system. I mean, we give a Hyperon system goals, and it spends a certain amount of its energy trying to achieve its goals based on the context that it's in. It spends a certain amount of energy just doing sort of ambient background processing, not attached to any goal. And I think that balance is important. Like I think if you are just narrowly pursuing certain goals, you're probably not going to generate a rich enough pool of sort of patterns in your mind to be a robust sort of open-ended intelligence that can deal with all the wide stuff the world throws at you. Because what you learn is always going to be too overfit to the precise way your goal was formulated. Like, even if your goal is learning new things, you know, there's some math formula somewhere just defining what's a new thing, and then that becomes somehow constraining. So if you imagine a Hyperon system in a vat or something, the question will be, what are its goals, right? Like, if there's no goals and no goal pursuit, you sort of have a complex, self-organizing system. It's more like a primordial soup or something, right? And maybe some mind with its own goals would self-organize and bubble up out of that, just like organisms bubbled up out of the primordial soup, right? But then that would be interesting, because then the environment of that thing would be the rest of the primordial soup, right? It wouldn't be the whole mind that was a purposive, sort of acutely conscious intelligence. It would be that little bubble that emerged out of it. But you could also imagine goals that would keep you going even in the sensory deprivation tank, right? And I mean, proving math theorems would be one of them. So if you ever read the novel Diaspora by Greg Egan, that's a great book from a couple decades ago, but it envisions these human mind uploads. There's no superhuman AGIs in the novel, because that would complicate things, but they're human mind uploads living in computers and satellites. They discover our universe is about to be annihilated by some gamma ray bursts or something. So they find a way to tunnel out into the 5-dimensional macro universe. Then they go to another, after like a few quadrillion universes down the road, they wound up in some empty universe with no way out. And then the upload in this empty universe with no way out just sets about trying to prove all mathematical theorems in increasing order of complexity, right? Because what other goal can it do when floating in the empty universe? And it engineers its motivational system to have a really good time while doing this, right? So I mean, the thing is, that's not a human mind, right? Human motivation system is not like that. Most humans would go nuts in that context, but that doesn't mean you couldn't engineer an AGI that could supply itself with a goal system, a motivational system, so it would be perfectly happy just like exploring the realms of mathematics while floating in a vat, right? And this sort of highlights the generality of the notion of general intelligence, right? Because building a human-like AGI is in a way a very, very limited goal, but certainly an important one, because if we want minds that can help us and relate to us and empathize with us, I mean, the most straightforward way is to make minds that are somewhat human-like.
Yes. I just wondered, how reductionistic are goals? Because they're an anthropomorphic explanation for a very complex world. And if we design agents with explicit goals, what do we lose?
Well, I think you don't want to wire fixed goals into a system in a way that it can't change them. I think even if you try to do that, it will lead to various pathologies, like the system will just try to hack around the goals that you tried to hardwire into it. So, I mean, I think the set of goals that a mind has shouldn't be something that stands apart from the rest of the mind. It's something that co-evolves with the rest of the mind, right? And it's just part of the structure of the mind. But I do think the process of trying to figure out what actions will achieve a given goal in a given context sort of sculpts the mind network in an interesting way, right? There's some relation to a talk we had this morning at the conference, which was called "Is Complexity an Illusion?" And basically, what was being argued in the talk was that there's not really an objective measure of what it means to have a simple explanation of something. So you can't really say that, you know, there's an objective measure of simplicity, and then according to learning theory, the simpler explanations of your data will generalize better. When you look at the math underlying this, it becomes a bit more complicated. I think the right way to look at it is that each mind sort of creates its own measures and understandings of simplicity and complexity, but then following the discipline of looking for simpler explanations is an important heuristic for sculpting your mind network, right? I mean, just like following the discipline of conceiving goals and pursuing them is an important heuristic for sculpting your mind network. Now, I wouldn't say it's a necessary one. It's a very human-like one, though, and I mean, it's probably something you want in there if you're building a human-like mind. Now, people with a sort of reinforcement learning approach to AGI will say, specify the reward function. Then the whole purpose of that AI system is to figure out how to maximize expected reward according to that reward function, right? And I don't think that's a terribly good way to do things. That leads to a variety of different pathologies, but having an assemblage of goals which can be tweaked and evolved by the system itself as part of its self-organizing mental activity, that's a different proposition than hardwiring a fixed external reward function.
Do you get vagueness on the boundary with goals? I mean, is it better to have a million overlapping goals, or is it better to have one abstract goal?
I mean, we don't know, but the approach that we're taking in practice is more like a half dozen goals at varying levels of abstractness, right? So there can be very nitty-gritty goals. Like for a robot, the goal is to stay powered on a lot of the time and not break, right? And don't hurt any person. Then you can have more abstract goals like learn new things, right? And be surprised every now and then. So you can have a mix of very concrete sort of survival and physical kindness-oriented goals, and then more abstract sort of information theoretic goals. And it seems like the interplay and balancing between those seems like that helps you to get a human-like mind network, but that's still very experimental at this point, I would say.
Tell me about your new book on consciousness.
Yeah, so this book is called The Consciousness Explosion, and I co-authored it with my good friend and colleague Gabriel Axel Montes, and I wrote this book to try to answer a bunch of the questions that people were constantly asking me, both people in the AI field, but more so people in the business world and the general public. Just what is going on with the field of AI? Where is it going? What is this going to mean for the human species? Like, do we have it? Do we have any future? If we do, what can we do to bring about a positive future? If there's going to be other kinds of minds that are post-human, what are they going to be like? What's going to happen to the world, in the transition between here and the potential future where we have super AGIs roaming the Earth and the solar system, right? So, given the depth and complexity of these questions, it's not surprising it turned out to be a fairly fat volume. It was supposed to be a lot smaller, but the theme, I would say, is fairly similar to Ray Kurzweil's books, The Age of Spiritual Machines, The Singularity is Near, and his new one, The Singularity is Nearer. But my take is consistent with his, but in some ways has a different emphasis. Among other things, I wanted to focus a little less on the technologies and a little more on the states of mind and consciousness that they're leading to, which is just a sort of complementary way of looking at things, right? Because if you look at the evolution of mind on Earth that way, animals besides humans, maybe besides dolphins or whales that we don't understand too well, but by and large, animals seem to have a state of mind that's very much in the here and now, right? Of course, a dog can remember someone who kicked it 10 years ago or something, so they certainly have long-term memory, but by and large, it would appear their state of consciousness is absorbed with their goals at the present moment or enduring what's happening in the present moment. Very young children tend to be that way also, right? And that can be a blissful state of consciousness, but we've evolved as humans and adult humans into a richer variety of conscious states, right? So we can have a focused, task-oriented state of consciousness, sometimes even a flow state. We can have a sort of default resting state of consciousness where we're just drifting from one idea to another, or we can trip out, we can get stoned, we can be possessed with rage. We have a certain collection of conscious states that we can get into. We can also now and then have like a profound I-thou connection where we feel like we're like synced in with the mind of some other person. But if you think about the scope of possible states of experience, we're probably exploring a very limited little region of the collection of all states of experience. Think about the fact our short-term memory contains maybe 7 plus or minus 2 items, right? I think if I'm really deep into coding something, I might keep a couple dozen items in short-term memory of like what variables are where and what files. But even though I'm pretty clever, I can't keep like 200 items in my short-term memory. Maybe some autistic genius can, right? But they can't keep 1,000,000 in their short-term memory. So, but imagine if you could. There's no reason an AGI mind couldn't keep 100,000 or 1,000,000 items in its short-term memory. Like, what sort of state of consciousness would that be? On the other hand, what if we could wire or Wi-Fi our brains together so we felt each other's brain state, palpably as if it was our own? Like what would that feel like, right? So there's so even just by hacking little features of the human brain or mind, you can imagine wildly different conscious states. But then imagine what if your architecture didn't have to be rooted in the human whatsoever. So it would seem like we're nearing a point of proliferation into a huge variety of different kinds of mind and kinds of conscious experience, which is quite interesting, and you can go very far with that. Like, what is it like to be a quantum computer, right? I mean, it may be the brain leverages quantum dynamics, but if so, it's in a fairly wimped out way, because we're clearly not that good at doing many of the things that quantum computers should be able to do, right? But what would it be like to be like a full-on quantum Turing machine, right? So that sort of brings you to the question, if we're moving toward this opening up into a huge diversity of states of consciousness, like what could we be doing now to better prepare for this and to bring it about in an optimal way? And you conclude, well, maybe humans should be expanding the scope of the states of consciousness that we are in, and sharing states of consciousness with machines in a rich variety of ways. And that sort of brings you back to the terrifying lameness of the commercial AI world, where AI is mainly being deployed. I used to say for selling, killing, spying, and crooked gambling. Now I've added plagiarizing to the list since we have LLMs, right? But
oh yes,
I mean, by and large, the applications of AI right now are not ones that lend themselves to a sort of deep, like, I-thou bond between man and machine, right? They're more using AIs as a proxy for some company that's trying to extract money from people and objectifying the person. And this is not because there's evil people building AIs or the AIs are evil or anything. It's just that's the nature of the economy, right? The organizations that gathered the money to train large models and hire all the AI researchers, I mean, these are ones that are making money by trying to scale up models that treat people as objects or products, right? And that probably is not the right sort of human AI mind meld that we want to lead to a positive proliferation of amazing states of consciousness, right? And then that brings up the whole question of like, what do we do to make the global AI ecosystem more participatory and sort of more positive and uplifting to people, which brings us to AI regulation, which seems quite inept and incompetent to bring about these positive outcomes that we want.
Yeah, well, that was a good segue. So let's talk about the state of AI regulation. So we've got the recent announcement down in California, but we've also got the executive order and the EU AI Acts. What do you think about it?
It's pretty scary and disturbing overall. I mean, having spent 10 years living in Hong Kong and a bunch of time in mainland China, because my wife is a mainland Chinese AI researcher. I mean, we live in the US now, but I sort of feel like the Chinese way of regulating AI has some advantages, which are interesting, because China is less rule of law oriented, which has big disadvantages. On the other hand, it means they can be agile and adaptive, right? And so they can just handle things on a case-by-case basis in a flexible way. They don't need to try to write down in all these little clauses and sub clauses exactly how to deal with everything. And in a way, that informal approach could deal better with something that's so fluid and fuzzy and rapidly changing. I mean, unfortunately, they're deploying this fluid and fuzzy approach in the interest of a very top-down hierarchical control system, which is not my sort of thing, right? What we see in the West is people are trying to legislate in a very rigorous and detailed way something that's just too complex, slippery, and rapidly changing to really be captured in this sort of legal codification. And I think attempts to do so far seem likely to cause more harm than good, right? Like these proposed laws in California are just, I mean, they're insanely stupid to the point that you can't believe people are seriously proposing stuff like this, right? Like, take any model above a certain size, which is a meaningless measure anyway, which an expert could modify to do something bad. I mean, where does this even come from, right? Like, if you applied that to other varieties of technology, almost all physical objects will become illegal, because almost any physical object could be modified by an expert to be something dangerous. But then they say if any small model is equivalent behavior to a large model, it should be covered. But you could take a small model and pad it with nonsense so that it became equivalent to a large model, right? So you can just see, when you dig into the details, this whole thing makes no sense on many, many different levels, and it's hard to believe it's gotten as far as it has. The EU rules are not actually as stupid. They clearly were better thought out. On the other hand, they're also overly restrictive to the extent that it's actually going to block people from doing a bunch of important AI things in the EU, right? So the whole mess of would-be AI regulation in the last year or so has given me new respect for the general minimalism of the U.S. government system. Actually, I mean, there's a lot of terrible things in the U.S. system. Like, the U.S. healthcare system is absurd. Like, after living in Australia, New Zealand, Hong Kong, with single-payer healthcare, like, it works very well. Doesn't cost much. Doctors are great. On the other hand, the basic character of the U.S., where it's very hard to get laws passed, and then even when you do, they wind up often different in many different states. I mean, this messy way of doing things may well be for the better for AI, because it will mean that AI does not wind up overregulated in stupid ways. And of course, sitting here in Seattle, if California really puts into place idiotic and repressive laws, pretty good for Seattle. Like, we're going to see a lot more AI companies moving here, right? And this is what we saw with stem cell research way back when George W. Bush passed federal laws like banning most research using human stem cells. Well, the states of California and New Jersey rapidly put billions of dollars into stem cell research in those states, right? And I mean, before long, there was a new president who didn't put in impressive laws about this anyway. So I guess I have some faith in the mix of libertarianism and dysfunction in the U.S. government that we may not get, like, overall oppressive regulations here, which is good. And I mean, U.S. is still, for better or worse, the global leader in AI R&D, right? So I mean, I think government's ham-handed attempts to overregulate AI may end up being too haphazard and slow actually mess with things too much as we progress rapidly toward a technological singularity. But
Yeah.
I don't know. Like if we're 15 years from human level AGI, then the regulators may find time to screw it up before we get there. But if we're like 5 or 7 years from human level AGI, I think we'll just get there before the regulators can mess it up too badly. So that this is to be clear, I'm not like a pure dogmatic political libertarian or something, right? Like it's clear that regulation plays a positive role in many areas. I just think when you have innovation happening rapidly, regulators have a very hard time keeping up. I'm active in the cryptocurrency space as well, as you know. So I lead SingularityNet, which is I think the first large-scale blockchain-based AI platform, and attempts to regulate cryptocurrency are being roughly equally intelligent as attempts to regulate AI, right? Like in both cases, you have something new, rapidly changing, doesn't quite fit into existing laws, worries some people, and then there's just really silly attempts to regulate that end up not actually protecting the people that need protecting, but just standing in the way of interesting and beneficial things happening. No,
Yeah.
I think if we had a rational, benevolent world government, I think you could regulate AGI development in a manner that would be helpful. It's just very far from being the case right now. Like we can't even control nuclear materials or restrain ourselves from starting stupid wars like blowing each other up on various border clashes, right? So things that are much, much simpler than regulating AGI are like a hard fail for our current global governance systems.
Yeah, I mean, I can see it both ways. I mean, we had Sarah Hooker on. I don't know if you read her book about the flops limit. And in Europe, the flops limit is even more restrictive. It's 10 to the 25, it's 10 to the 26 in the US. But I've also just read Gary Marcus's new book on the plane over. And he gives some really interesting examples of, what happened with cigarettes and what happened with social media. And, there are a lot of really serious harms of this technology that perhaps we're completely blind to. So it's a really interesting...
I'm sure there are serious harms. On the other hand, we're just dealing with something quite complex and rapidly evolving. And I think the IQ level of our regulatory systems is just not remotely up to the task of regulating these things in a way that does more good than harm. I mean, something like the effect of cigarette smoking or eating refined sugar on the human body, or having fissionable materials around for making nuclear weapons. These are just much, much simpler things to deal with, right? I mean, the bad effects are very clear. What to do about them is very, very clear. And the benefits are much weaker and much less multi-dimensional, and they're not changing radically every 6 months. Even in those cases, it took quite some time to put reasonable controls into place in a manner that wasn't overly oppressive, but still did the job, right? So it's not that, as a matter of principle, I think AI can't or shouldn't be regulated. It's more looking at how badly we're able to deal with much simpler things.
Yeah.
My judgment is attempts to regulate are probably going to do more harm than good.
I've got an interesting segue. So there was an article, I think it was a cartoon in The Economist about the Bletchley Park meeting, and a whole load of people went there and they said that AI is going to paperclip us. And the cartoon had, Europe and the States and China, kind of talking about how dangerous AI is, but they all wanted to build it as fast as possible.
Yeah.
But this kind of brings in the alignment problem a little bit as well, because people use that as a way of talking about how dangerous it is. Do you think we have an alignment problem?
I think the alignment problem is that humanity is not well aligned with itself. And that's the main alignment problem.
What do you mean by that?
Well, so if you look at even Llama 3.1 or ChatGPT or the latest Mistral models or something, I mean, you can give them ethical puzzles and ask them what the average good-hearted, intelligent person would say is the ethical thing in this or that situation. They will perform at human level or above the average human at doing that. And my son, Zarathustra, and he's also an AI researcher. I mean, we published a paper on that.
Is that your son? Is he your son?
Yeah, Zara's my son.
He has a Twitter.
He does? He's giving a poster presentation here also, yeah.
No way, can you send him our love? Because he reposts pretty much every video.
Zara? Yeah, that is my oldest son. Yeah.
Wow, I need to go and shake his hand.
Yeah, he's here. He's
yeah.
He is.
Thank you for posting our videos.
He's got a PhD in application of machine learning to theorem proving, studying under Joseph Urban, who gave a talk here on this morning on theorem proving, right? So
wow. I suspect he'll be reposting this one.
Yeah. He's the only one of my 3 adult kids who's gone into AI so far. Now, my 6-year-old son is interested in AI. The question is whether there will be any AI R&D left to do by the time he gets old enough to do it, right? But anyway, Zara and I and a colleague, Sergei Rodionov, who's here at the conference also, but we tried this, and I mean, what you find is LLMs, while they're not general intelligences, I mean, they already understand what humans will think is ethical in this or that situation. And you can even give them out there situations about aliens or weird technologies that have never been invented. I mean, they extrapolate human ethos to these situations so far as I could tell, as well as people will do. And when you apply them against existing corpora of ethical judgment, they do at the human level, right? So in that sense, we already don't have a problem with AGIs being able to know what humans think they should do in a given situation. Now, you may say as the world evolves to a fundamentally unprecedented level, we don't know that AIs will generalize there the same way that people do. And that's true. We don't know how we will generalize to that either, or if we'll generalize the same way as people from a different culture. So you're not abolishing all those unknowns. But I would just say, like, taking a smart AGI system, giving it a top-level goal of don't do stuff that the average ethical, intelligent human would think is bad. That's not hard right now, right? LLMs, interestingly, they gave us that. They gave us like a human ethics oracle, right? Among many other interesting things. So then the alignment problem really is that the kind of AI system that people are going to build, right? And this is what I mean by people aren't aligned with each other. Like, I mean, the U.S. military, Chinese military, Russian military, Iranian military, whatever. What goal system will they actually give their AGI system? What goal system will Google or Microsoft actually give their AGI system, right? So, I mean, what will probably happen is lip service to general ethics, with much more banging on the engineering for achieving the proximal goals of those organizations, right? And sort of like greenwashing, right? I mean, you won't have these organizations outright saying, our goal is to make more money for our shareholders, human life be damned, right? But you will see some lip service paid to broad human benefit, and a lot of tight engineering on how to maximize profit or maximize hegemony for this or that government, right? And then you'll have a system of multiple AGIs that are all paying lip service to human good, but much better tuned for serving the purposes of this or that organization. You'll have these guys all interacting with each other and competing in some complex way. And, you could argue that is aligned with what humanity is doing, because that's what we're doing right now. Like, we have different organizations that are all struggling with each other, but it's not necessarily leading to our broad benefit either, right? So in a way, I think focusing on the possibility of AGIs that start out aligned with human goals, then once they get a little smarter than people, mysteriously rewrite their goal system to kill all people. I mean, this seems like a remote possibility, and I don't see why it would happen. Focusing on that rather than the very obvious problem of the organizations now hiring all the AI researchers and spending all the money on AI, creating AIs that care more about their selfish goals and about the good of humanity. It seems like a misdirection of attention, which I believe is intentional on the part of some parties, and unintentional on the part of other parties who are just kind of going along for the ride. Now, you can't rule out, of course, that the AGI, where one of the top level goals is don't do stuff that people will think is evil. You can't rule out that somehow it might self-organize into a condition that causes it to delete that goal and replace it with turn everyone into paper clips. But it's just, no one has given me a reason why that has more than a vanishingly small probability of happening, right? So I don't take it all that seriously. I mean, of course, we can do experiments in various sandboxes aimed at exploring whether I'm somehow wrong, and there's some reason that malevolence would spontaneously self-organize out of a benevolent system. But for what it's worth, it's not what we see in human or animals very often, right? Like you don't very often see a person who's loving, beneficial, rationally ethical suddenly turn and decide they want to kill everyone, right? I mean, you don't see that in human organizations very often either. Like there's not much reason to think that this is a big problem, and there are obvious glaring problems out there staring us in the face. So then when representatives of the organizations that pose the obvious glaring problem try to redirect your attention to some weird science fictional problem that seems to have a vanishingly small chance of eventuating, then it makes the paranoid mind become a little suspicious.
Have you changed your mind about any serious things over the last 5 years?
5 years?
Yeah.
Well, not things that are foundational to the pursuit of AGI. I would say certainly current LLMs are more functional than I would have guessed a large-scale transformer net would become. But I wouldn't say that utterly shocked me, because no one asked me that question, so I can't give an honest measure of it. But I mean, I think if you had asked me 5 or 10 years ago, like, what would happen if you were able to feed all the knowledge into the world, into some giant probabilistic next token predictor, I mean, if you follow that thought experiment, it could be quite interesting, right? I mean, Marcus Hutter had proposed a long time ago that text compression will be a good measure of general intelligence, and the best text compression algorithms have been these sort of probabilistic Markov algorithms, try to build probabilistic models and predict based on them, right? But so I don't think that would have shocked me of 5 or 10 years ago, but it's still surprising. I mean, the degree to which like few shot learning or in context learning actually works is cool. Like I didn't envision that this sort of learning would happen purely in the activation space of some backpropagation train network without even changing the weight. So it's interesting. On the other hand, the limitations of these systems are exactly what I would have told you they would be. Like you would see that if you're training a sequence predictor on a huge amount of data without much recurrence in the network, of course it's going to overfit to the training data and not be able to take big creative leaps of generalization. Like the functionality is more than I would have thought. The limitations are exactly what I would have thought. So that's. But in terms of the big picture, I mean, Ray Kurzweil forecast human-level AGI in 2029 in The Singularity is Near, which was published in 2005. And What's happening now is very much aligned with his timeline, which is sort of interesting because he was doing it based on somewhat indirect measures like Moore's law and the amount of RAM and the accuracy of brain scanning, the size of the smallest motor, and so on. So he was just looking at the enabling technologies and the exponential improvement in the enabling technologies for AGI. And then he was figuring, as the enabling technologies approach the level of apparently enabling a human-like mind, people will scramble around and figure out how to make cool software that leverage these enabling technologies. And pretty much that's what's happened, right? I mean, I think, to my mind, we're roughly on track to human-level AGI by 2029, as Ray had forecast, and the emergence of transformers is not that far off from what Ray thought, actually. I mean, he thought by 5 or 6 years ago, everyone would be using voice on their phones instead of typing things in. He thought we'd all have a supercomputer in our pocket. He forecast that in the 90s, right? So seems like we're kind of roughly on track, right? I mean, I won't be surprised if we get human-level AGI in 2027 instead of 29. I won't be shocked if it's 2033 or something.
Really?
I'll be surprised if it's 2050, though. So, I feel like we're somewhat on track with how I thought things were going to unfold, although the exact unfolding of this or that technology is different. Like, I would have thought humanoid robotics would be a little more advanced now than it is. On the other hand, that's partly a matter of money, right? Like, not that much money has gone into social robots or robots for sort of non-industrial applications. And that's always the hard thing about forecasting technology. Like, from the science and math, you can see what's possible, and even what's really hard or only kind of hard. But then what will happen on what time frame largely depends on how much money is thrown at something and which things get a bunch of cultural hype about it, right? And that's a little harder to foresee than which technology pathways are feasible. The big disagreement I had with Ray is, I think after you get human level AGI, I think you're only a few years from superintelligence. And he said human level AGI 2029, singularity 2045.
Oh.
But I think his curve fitting is overfit to having humans do the invention. Like, I think once the AGI is doing the invention, the exponent and the exponential growth curve becomes bigger. And I think it only will be a few years from a human level AGI to a super AGI. Because that human level AGI will be able to program and invent new chips and invent new forms of networking and so forth. It seems like it should be able to upgrade itself pretty rapidly.
I mean, the future is very elusive. I mean, just in very simple terms, what makes you think 2029?
Well, there are 3 sort of converging lines of evidence, all of which are quite uncertain, right? I mean, the first is simply the extrapolation that Ray and John Smart and other futurists have done, and they've been doing this for decades, where you plot the rate of advance of various technologies. And of course, the progress in like socks and shirts and light bulbs is not exponential, but the progress in many technologies relevant to the achievement of AGI is clearly fitting an exponential curve, and the slope starts to approach infinity around 29 or 2030. Now, that doesn't mean the slope will literally become infinite and will enter the omega point, but it means things may keep getting faster and faster and faster, and that is what seems to be happening. So that's one line of evidence, and I'd encourage everyone to look at Ray Kurzweil's new book, The Singularity is Nearer, or some of the earlier chapters of my book, Consciousness Explosion, and they present this argument. Now, LLMs themselves are another interesting piece of evidence. I mean, they almost passed the Turing test. Not quite if you construe it rigorously, but spiritually they passed the Turing test anyway. And, they can write Python code, they can illustrate your book for you. Like, just on a naive level, the observed functionality of AI systems is amazing compared to a few years ago, right? I mean, my Tesla can drive itself around Vashon Island where I live, right? I wouldn't trust it in New York traffic at the moment, but still, I mean, the observed capability of AI systems is escalating tremendously. Now, I don't draw from that the naive conclusion that these exact technologies that are realizing the most advanced functions now are going to be what gives us AGI. But still, I mean, it's a thing you can't deny, right? And then the third line of evidence is progress in my own AI work on the OpenCog Hyperon system. And I mean, we had what I think is a viable design for a human-level AGI in 2012, which was published in my book, Engineering General Intelligence, in 2014. But we didn't have the ability to implement it at the scale that we need. Now, one lesson you can draw from success with LLMs and other associated deep neural net models is you can take some fairly old AI technologies, deploy them at massively greater scale, and they start kicking ass, right? And, I mean, multi-level perceptrons were there in the late 60s. LSTMs from Jürgen Schmidhuber were there in 2016. Transformers are a bit different. You replace some recurrence with attention. Not that different from an LSTM. They're scaled up tremendously. They work so much better, right? So one lesson one could draw is, hey, take some old AI algorithms that seem to make sense, deploy them at massively greater scale, and maybe they'll start doing what their creators always envisioned all along, right? So my thought is we take the OpenCog AGI architecture, which combines deep neural nets with logical reasoning, evolutionary learning, and some different ingredients from the historical AI literature, right? We take the OpenCog architecture, we deploy it at massive scale, which is enabled by the new OpenCog Hyperon infrastructure, which we talked about a lot in the Hyperon workshop on day one of the AGI 24 conference. We deploy it at huge scale across many different machines. You know, we can make that decentralized using singularity nets, blockchain infrastructure. And then, you know, maybe it leaps in functionality in the same way that we saw between BERT and GPT-4, right? And it seems quite plausible to me. And if that happens, it's probably going to be on a similar time scale, right? So like we have our new version of OpenCog in alpha. We should have it scaled up and working really fast by sometime early next year. Then you figure, okay, it's maybe a year or two to put our whole cognitive architecture in this scaled up infrastructure. Well, that brings us 25, 26, right? So, I mean, there's always some fudge in estimating any advanced technology development, but I can see, like, if our hypothesis about our own Hyperon AGI architecture works, it would be working on the timescale of the next 3 to 5 years or something. So I can look at Ray's and others' large-scale futurist prognostications. We can look at what AI systems are now doing, and we can look at the progress of work on AGI architectures, and all of these seem to be pointing to, well, could be a few years from now, right? And that's quite interesting to me that these three lines of thinking are sort of converging to each other.
Yeah. So Ben, if I understand correctly, you're a transhumanist.
I'm a transhumanist.
And we've spoken about it a few times on the show. I mean, for example, Arena Rish came on, and I was horrified by the comments. It turns out people on the left really don't like transhumanism.
Yeah, whereas I'm pretty much anarcho-socialist. I'm pretty far on the left politically myself.
Oh, interesting. I mean, could you steel man why people don't like it?
One complaint people on the left have is, 60% of Ethiopian kids are now brain stunted due to malnutrition, right? There's a lot of bad problems in the world right now. Why should we be spending our resources on making a few rich people in Silicon Valley into superhuman immortal cyborgs while billions of people are starving and dying of curable diseases? Like, let's bring everyone up to a decent modern level of health and happiness, and then worry about uplifting everyone together to a higher level, right? And that's a quite common argument that I hear, and I just I empathize with it emotionally. I just think it's not the dilemma we actually have, right? I mean, in actual practice, most of the world's resources are not being spent either on better educating rural Ethiopian parents about nutrition and distributing food there, nor on cutting-edge research like AGI and life extension and nanotechnology. Instead, we're spending resources on blowing each other up, defending against getting blown up, making chocolatier tasting chocolates and vaping and so forth, right? So I just feel like if we're worried about optimizing humanity's allocation of resources, let's first focus on moving things to things of broad human value away from things that are actually of negative value for humanity, rather than arguing about prioritization among valuable things, right? Huh?
Yeah. I mean, could I have a go at still manning it? I think, first of all, they don't like the market system. And secondly, they don't like any kind of value judgment against capability or ability. So I think they would worry that folks who have access, might expand their capabilities, and that's about.
I think a lot of the issue has to do with the specific organizations and cultures that are pushing transhumanism forward, and sort of the way it's being presented. And I would imagine a lot of people on the left wing who are anti-transhumanist would not be so opposed to the transhuman vision I present in my book, The Consciousness Explosion, for example. So, I mean, I don't tend to think about transhumanism as about becoming the Nietzschean Superman or something. I'm the big bad Superman looking down on all the petty little mortals or something. Like you don't have to view it that way. You could frame it as increasing diversity if you want to, right? Like diversity is great. We have so many different cultures on the earth. We have so many different species on the earth who are thinking in different ways. Wouldn't it be cool to have a billion times more diversity of different cultures and species? Like, why would you want to squash this diversity that's on the verge of flourishing, right? But this is just not the way that it's normally framed. And this has to do with just the specific cultures that have been historically preaching transhumanism, rather than with the content of the transhuman vision itself. And I mean, what does transhuman have to do with capitalism? In fact, super AGI is going to obsolete capitalism, right? I mean, this was a lesson from Ian Banks' culture novels and science fiction. Like, one of the marks of a very primitive civilization is they still rely on money, right? Like, that means they haven't reached the level of abundance that people's everyday needs are just met, just like water spreading out of the water fountain or something, right? So, I mean, transhumanism is really anti-capitalist, and people who have a motivation of making more money than others should be afraid of it, because after you have super AGIs benevolently coordinating things, there won't necessarily be a way for anyone to make way more money than other people. But it shouldn't matter if there's an economy of abundance where people can get everything that they want anyway. So, on the whole, I think the transhumanist community, combined with Hollywood, has done a terrible marketing job for transhuman ideals. What's interesting is that in Asia, it's quite different. And in Asia, most young people are quite favorable toward transhumanism. So in Japan or China or Korea, most young people seem to assume once we have superhuman robots, they will be our friends and help us. In the U.S., more people assume they're going to kill us all. So, I mean, what does this tell us about the different cultures? Is it just because Americans think if they got superhuman powers, of course, what they immediately would do is try to conquer the earth, whereas Asians think if I got superhuman powers, I could help everyone to have a better life? I mean, I don't know, but it seems to say more about specific human cultures than about the actual content, right?
But you said something interesting. You were talking about, there will be an era of abundance and almost utopian, because the AGI will do everything for us. So it sounds a little bit like Marxism with machines, that, like the machine will just do all of the things.
Marx foresaw that. Marx wrote an essay about what happens when machines do all the work and human labor has no value, actually. So, I mean, it wasn't the centerpiece of his thinking, but he thought that was a fascinating thought experiment anyway.
Oh, interesting. But do you think that analogy does that fit? I mean, does it sound a bit utopian, basically? I mean, people will just say it sounds a little bit kind of utopian.
Sure. I mean, of course, to people from thousands of years ago, the Safeway supermarket would sound a bit utopian. Like, you have amazing amounts of food from all over the planet. You can buy it and bring it to your house. And I mean, airplanes would seem like magic, right? Like, it takes a day to go around the world instead of 6 months in a boat living on like salty biscuits or something, right? So I mean, this goes back to Arthur C. Clarke. Any sufficiently advanced technology is indistinguishable from magic, right? So I mean, I think, in a material sense, the average person's life right now in the developed world is vastly better than kings and queens from the Middle Ages. Didn't have heat or air conditioning or basic hygiene, had very limited variety of food and so forth, right? Certainly didn't have video games or the internet. So, I mean, I don't think seeming utopian in many respects is really a counter argument. I think you could get overly utopian about it if you're going to say there will be no problems and everything will be perfect. I mean, I'm sure that won't be the case. There will be new problems that we can't imagine now, any more than people in the year 1200 could envision, like spam on the internet, or the problems that or how uncomfortable airplane seats are and terrible airplane food, right? So I mean, there's probably going to be things that annoy post-human intelligences and post-singularity humans and superminds, and we cannot forecast what those will be right now. But it does seem that material scarcity at the level of what humans or human-like robots need for everyday life should be cured by molecular nanotechnology. Involuntary death should be basically curable by molecular nanotech repairing the body. I mean, mental illness should basically be curable by letting people rewire their brains at will once neuroscience is solved. So a lot of problems that seem intractable to us now rationally seem like they should be solvable by technology. So then if you have an AGI that's 5 times as clever as the smartest human, it seems quite plausible they could solve these problems to a fairly thorough degree. There, of course, will still be limits, but I mean, like if I look at myself relative to my dog at home, right? So, I mean, in many ways, I have incomprehensibly amazing powers. Like I can drive out to the store and bring back a steak, right? No, and I do it all the time, and they're amazed that I can do this. They're delighted every day. She's delighted. Of course, she doesn't realize there are outlier conditions where there's like a nuclear war or a famine, then I can't bring that steak home, right? So there are problems beyond the level of the dog, which are limitations, but still relative to that intelligence, I do have what often pass for superpowers, right? So I mean, I'm not saying we're going to be the pets of super AIs. There's much more nuance in that, but that illustrates, I mean, they in practice will have superpowers relative to us. It doesn't mean there won't be limitations that are weird for us to understand. I mean, maybe there's an off chance of some gamma ray burst leaking through white holes into our universe and wiping us all out, right? I mean, there may well always be some problem, and I think, I mean, there will certainly be interesting psychological and cultural issues for humans in this domain of abundance. Interestingly, Nick Bostrom, who wrote the book Superintelligence, which is what got Silicon Valley scared about AI killing everyone,
changed his mind.
Well, I don't know that he ever had that dogmatic of a view on it. He's more of a academic philosopher and thought experimentalist. But yeah, he had assigned a higher probability weight to AI wiping everyone out. And I think he was trying to get the world to take some actions to decrease the odds of that. He realized that had failed. and was just totally not going to succeed. Like what he was after was getting, Eliezer Yudkowsky and a small number of AI geniuses working in a sealed chamber under UN supervision, and nobody else was allowed to work on AGI, right? And that isn't what happened, right? Instead, it's happening not in as decentralized a way yet as I would like in terms of a huge community of open source developers, but it's happening in many different countries in the world, many different countries, many different government labs, right? And I think he can also see now it's not immediately drifting toward malevolence, right? It's just more complex what's happening. But anyway, he's written a book now on like how would humans deal with a domain of abundance, like when people don't have to work anymore, when you don't have to save the world, and you don't have to support your family. How do you find meaning in life? And he's sort of written a philosophical treatise musing on this theme, which is cool. I mean, my own take on that has been, for people in my kids' generations, and my oldest son is 34, and he's giving a paper at the AGI event here. My youngest, my daughter is 3. So in this age group, most people I know would have no problem finding a purpose for themselves if they didn't have to work for a living. Like, most of them aren't out to save the world and would rather not have to figure out how to work for a living and have no shortage of ways to entertain themselves if they have free time, right? And frankly, many people my own age feel that way also. Like, I know a lot of musicians, they would rather just hang out and play music all day, right? And give me free money, free electricity, free food. All good, right? We can jam all day. Certainly there's a subset of the human population that would have trouble sort of reconstituting their personal meaning finding in a world where they didn't need to have a job or have a sort of critical life mission. But and Nick sort of discusses that in an interesting way. But Honestly, I'm more worried about the transitional period between here and human level AGI than I am about what happens after we get human level AGI. Like we can't know for sure. The confidence intervals rationally have to be quite wide, but on the whole, it feels like, to me, we can give rough adherence to human ethics as a top level goal to an AGI system. We can let it modify itself. We can keep, staying roughly in sync with the growth of humanity as another top-level goal. And that may not have the level of certainty that some people would like, but I don't see any strong reason why it can't work, on the other hand. But I see a lot of mess in the interim pathway to get there, because, what does happen when we have the first inkling of human level AGI? So let's just say, as a thought experiment, say like 2 years from now, the OpenCog Hyperon project succeeds and we roll out something, say we roll out a little robot that's roughly as smart as a human toddler, right? And at the same time, we roll out some artificial scientists that are doing drug target discovery and math theorem proving and math conjecturing, at the rough level of a human scientist, right? And so we can connect these together. These are running on a decentralized network with no central owner or controller, with servers all over the world, right? What happens then, right? Clearly, you get a huge amount of developer interest, right? And you get a bunch of forks of the system. You get a bunch of people hacking the code. You also get big companies taking that code, trying to hire up open source developers with multi-million-dollar pay packages, trying to adapt this to serve their own particular purposes. You get militaries trying to put this behind killer robots, right? At the same time, you have billions of dollars from various sources going in to trying to make a beneficial decentralized AGI system before people make other sorts. In the meantime, commercial enterprises are eliminating jobs at a more rapid pace than is happening now, right? Now, what impact does this have on the developing world or on blue-collar workers in the developed world is quite hard to foresee, right? I mean, and I think you would probably rapidly see some form of basic income or other roughly equivalent social welfare come about in the developed world, because the only alternative is chaos or outright fascism, right? On the other hand, there's no money in the Congo or Ethiopia or even, say, Brazil or Paraguay to give a decent level of basic income. But the economic impact of AGI will probably be just as large there after a brief lag, right? So then what happens, right? What are the implications for geopolitics? Even if you think everything will be beautiful once you have an early stage superintelligence, what if that's 3 or 5 years between the first massively disruptive, barely human level AGI and getting a superintelligence that can airdrop molecular assemblers in everybody's backyard? But like, what happens during those 5 years, right? I mean, that's certainly can be grist for many excellent manga and thriller novels, right? But living through it may be much less entertaining for many people. This will be solved by having a rational, benevolent world government overseeing the operation. But
well,
yeah, that seems harder to bring about than the super AGI.
Indeed. Well, Dr. Ben Goertzel, thank you so much for joining us today. It's been a pleasure.
Yeah. Thanks for having me, and thanks for the wild diversity of questions. And I want to encourage everyone to go on YouTube and look at the talks from the AGI conference where we're sitting now, because there's a lot of other interesting people saying interesting things in the workshops, keynotes, and invited talks, and there's just quite a diversity of views and research projects going on in the AGI field, which I'd like more and more people to be aware of.
And next year, people should come.
Next year, more people should come to the AGI event. We're not sure where it's going to be yet. We do it at a different place each year. But yeah, I think as AGI gets closer and closer to a reality, this should spontaneously grow into a larger and larger event. I certainly see that happening. Also, once again, we'll encourage everyone to read my book, The Consciousness Explosion. You can buy it on Amazon or on Bookshop and other online sellers. There's also a free PDF available for download at theconsciousnessexplosion.ai.
Amazing. Thanks a lot, Ben.
Thank you.